Physics is the study of natural phenomena, that is, events and processes that occur in the physical world and can be observed. A phenomenon refers to anything that happens in nature: the motion of a falling object, the propagation of light, the flow of electric current, or the expansion of gases. These are real observable events that can be investigated. The starting point of physics is therefore observation. Observation involves using our senses, directly or with instruments, to detect and examine aspects of a phenomenon. Scientific observation focuses on identifying what can be measured. In physics, these aspects are called physical magnitudes. A physical magnitude is any quantity that can be assigned a numerical value and a unit. It describes the extent of a property. Examples include length, time, mass, volume, and temperature. They move us from vague descriptions to precise quantitative statements. Physical magnitudes are divided into two important categories: scalar quantities and vector quantities. A scalar quantity has magnitude only. It tells us how much of something there is, but not the direction. Examples of scalar quantities include mass, time, temperature, energy, and distance. A vector quantity, on the other hand, has both magnitude and direction. It tells us not only how much, but also which way. Examples include velocity, force, displacement, acceleration, and momentum. This distinction is fundamental in physics. Direction plays a crucial role in how physical quantities combine and interact. Problems cannot be solved without this recognition. Once phenomena are measured, we introduce concepts. Concepts are the ideas and terms used to describe and organize observations. They form the language of physics. For example, velocity describes motion with direction, force describes an interaction. Concepts are not just definitions, they are tools for thinking. They allow us to classify phenomena and build relationships. When concepts are properly understood, they enable scientific thinking, analyzing relationships and building models. Physics then becomes not just descriptive, but predictive, and we can predict how an object will move under different conditions. This is formalized through the scientific method: observation, description, and measurement. Then hypothesis, experimentation, analysis, and conclusion. This process leads to reliable scientific knowledge. To learn physics from first principles is to return to the foundation. Start with what is happening and what can be measured. Understand the language used to think, connect, and predict. This builds deep understanding rather than relying on memorization. Instead of asking, "What formula do I need?" you begin to ask, "What is physically happening here?" Physics is not just a collection of equations, it is a structured way of understanding reality: observation, measurement, concept, understanding, prediction. Master this process, and you begin to think like a physicist.